So if we come back to the field now, all these exercises I've just gone through was just to explain how a value can change in a field. And this is by thinking about the point. If this is a point in a field that is rotated, so you could still see this here. Okay, yeah. So this point is rotating in the field. This is the field. This point is rotating. But it's not, you should not think about that rotation. That rotation, which I described as being a plane in X and Y. So it rotates here in this space here. This space is not this space. This is you could think about it as an internal space or an instinct property of the field. What I'm saying is this thing has an instinct rotation and this is a mathematical tool to describe that rotation. And that mathematical tool doesn't exist. It's something we use to explain why this rotates. And it's something we use to explain why the value change. And the explanation was this bowl shape inside that field. And that bowl shape was connected, was mapped to the z-axis. And that value which this rotation has on the z-axis is the value that is represented in that field. And for instance, if we now say this point here, the value of this point change like this over time, that means we will have this value is going up and down over time. And if we plot that value in the field, we're not thinking about this anymore. We're thinking about how this value here changes over time. We will get a wave like this in that particular spot. Then we could take another point over here and have that changing just in the same way. And another point here changing just in the same way. And another point here just changing in the same way, etc., etc. And if each of these points has a little bit shifted wave. So if this is the point 1 and this is point 2, point 1 here, and then we have point 2 here. And let's say it's shifted. So this peak here is not over here. But here is a valley. I'm just going to draw this so I draw it right. So this is like this instead. That should be a minimum, a maximum, a minimum. So you could see that like they're not the same, eh? They're different, shifted. So 2 is 1 but shifted in values. And then if we look at those values here in the field, if you take all, so this is positions in the field. So if we look at this particular line in the field and the values which are there in the field, those values in the field position value creates a wave too. And since I said the value in that point is changing over time, so this here now, this here, or this here rather, this is a plot in space by position, but over time, so this is like say 1201. At another time point, 1201, this wave may look like this. So this is a fixed, at that time point, 12 o'clock, that's a snapshot how that wave looked like at 12 o'clock. But 1201, the wave looked different, because every spot here inside is changing value all the time. So it means you have a wave that goes up and down there all the time. And this can, if we go back to my previous video, this can be interpreted as a wave in the field. All these things. So let's see if I still have time. Yeah, okay. So we've gone a very long way now, and I want to sum up this a little bit. We started out with a box where we made an observation of something, a ball or whatever, a particle, at the time point 1200. And then we left this room and came back and was making a new observation here at 12.01. And at 12.01, that ball was gone, and then we have a ball here. So we have a situation that looks like this. 12.01, no, 12 and 12.01. The ball is here, and then the ball is here. And we asked ourselves, how did the ball go from here to there? And in our journey to try to explain this, we first said that there is a field. So this is at 12 o'clock. At 12 o'clock there is a spike in the field here. And then at 12:01, that spike had moved to somewhere else place in the field. And then we said that the reason for this spike to be there was because there was some kind of wave in here in the field. So we said there was some kind of wave here in the field that had moved over to over here. Eh? That's what was said. And then, in order to explain why we had all these values in the field, I would go into a specific point there, and then I was saying there is another space, and in that space there is a bowl, and the shape of that bowl I called energy levels. Energy. I also said that this field here didn't exist. And then I also said that these things here didn't exist. This is a representation of that point. And that point in itself didn't exist. But I also said there was different viewpoint we could have on this, that this bump here in the field could be thought about either as some intrinsic thing with the point itself, where the values went up and down in that point. Or I said that, so this is a point in the field, or I said that there may be something here in the field that moves, and that's something we could associate with energy or a pressure or whatever that moves in the field. So it's this something that affects the point. So what we have like is we have internal reasons, or we have external reasons. What I want to come to here is, we started out in the beginning, we're asking how small pieces can we grain matter into? And the Greek said, like, yeah, well, there has to be a stop somewhere, a smaller unit. Okay, so once we had identified that smaller unit, we wanted to start inspect what this is made up of. And we found out that, well, it's what I called these things events in space. This thing here wasn't a real thing. This is an event. And this is an event. An event is something that occurs in time at a specific position. And then in a little bit later time, it's gone. And then some else event is created. Okay? So in order to explain these events, we made up a field with a wave in it. And we said that when we did an observation, there was an event in this field, and that event is related to that observation we did. But I said that this doesn't really exist. I said this doesn't exist if there is an internal reason for why the values goes up and down. Then this doesn't exist. But I said that the bump here could be thought about being existent if we have an external reason for its existence. And I said we couldn't know what the reason was because we hadn't observed anything here. This is not observation. This is just like something we made up. And the reason we made it up being bumps in the field and these things is because we're using wave mechanics to explain these things. I told you earlier you could use matrices to explain the same thing. So is it matrices then? No, it isn't. It's what we interpret this is as depending on the mathematical tool we are using. So we can't say it's really a wave, and that's my point. And we're using wave mechanics because it's easier to visualize it. That's the reason we're using wave mechanics. Matrices, we can't really visualize it, but wave mechanics we can visualize. So this is a visualization, but it doesn't mean this is the way matter and reality is. What it means is, the only thing it tells us is that, and the reason we're using it is because the prediction it makes correspond to our experience in reality. And with here, I have to break this and make a final video where I sum this up.